All right, good morning again, everybody. Happy, ano yung araw na ba ngayon? Happy Thursday. So malapit na mag-weekend, matatapos na yung first week of the SEM. I heard that registration is extended. So medyo pwede pa kayo mag-relax a couple more days. But I hope you already got your units. Tapos na yung hustling and bustling ang hustle and bustle ng registration period. So today we'll start our discussion about inverse problems. Pero yeah, sabi ko kanina medyo madaya ako dito sa 191 because I suspended my other class orientation lang this whole week. But the thing about our course ay hindi ko pa na-finalize yung course timetable, yung course calendar natin. So dulo, so why not use this day to start introducing inverse. Binigyan ko na rin kayo ng homework or reading assignment para sa next week, all right? But let's try to keep it as informal ba ang term, or non-mathematical for now. So we will limit the amount of new mathematical information. Wala muna tayong mga operators na i-consider. Wala munang heavy math, ano? So here, I'll just spend this session today just to introduce what inverse problems are and give you an idea kung ano yung pag-uusapan natin all throughout the semester. So I'll give you a couple of illustrations, nice illustrations, and a bonus quiz, a popper quiz later. And then, yeah, siguro pwede ko ring bawasan yung reading as sorry, na-cut off yata ako dun. Pero kagabi, binabrowse ko yung reading assignment na binigay ko sa inyo at medyo mahaba pala siya. So probably, you'll just need to read half of the reading assignment I gave you. Tapos yung second half ay pwede nating i-discuss sa lecture on Tuesday. But if you really have the time, so it's it won't hurt to read the entire material that I shared with you guys, all right? So just a quick show of hands. Don't worry, hindi ko kayo i-judge kung hindi nyo binasa yung module. Pero sino na sa inyo yung nagbasa ng module? I mean this part. Yung here we go part ng module. Okay, si Prince. Kasi self-explanatory to. So kung nabasa nyo na, so konting-konti na lang talaga yung gagawin ko today. Oh, nice. Mukhang marami na yung nakabasa. Pero if you notice, this is just parang sort of a non-specialist introduction to what inverse problems are, because I said here na all throughout our mathematical careers, or as you as students, encounter natin na yung mga tinatawag natin mga forward problems. Meaning what we do is governing principle. So meron kang governing principle or equation. And then, given tayo ng mga inputs to that governing principle. All right? So the governing principle can be a set of rules. Like halimbawa sa 101, tinuruan kayo kung paano nag-work ang connectives, how and, or if and only if then, disconnectives, how they relate propositions to each other, and then ang inputs, so yun yung governing principle, and you can think of the inputs to be propositions. You have declarative sentences as the input to your phenomenon. All right. And then we look at the interaction between these inputs guided by the governing principle to get a particular output. So sa Math 101, ang particular output na kinonsider nyo ay yung truth value nung compound proposition. Sorry, example, kasi I know all of you have taken Math 101 na. So ganun yung idea. Merong isang governing principle. It could be an equation. It could be a set of axioms, a set of rules. And what we want to do is to play with some inputs in that universe para ma-predict o ma-compute ano yung intended output. Right? So in a more simple example, halimbawa, yung governing principle ko ay arithmetic. All right? And my inputs are 2 and 3. All right? And then the phenomenon is the addition phenomenon, which is a subset of the governing principles that were laid down. So sa arithmetic, nung elementary, pinasolve sa atin 2 plus 3. This is an example of a forward problem because we're starting with the inputs And then we want to do something about these inputs. We want them to undergo a certain process, which is governed by a certain principle. So dito ang principle natin ay rules of addition, or in a more generic sense, arithmetic, right? Tapos ang problem is find the output. So in this particular case, yung 5, siya yung output natin. So that's the forward problem. This course is focused more on the inverse problem. Ibig sabihin, as the name implies, babaligtarin lang natin yung situation. What we know now are still the governing principles, all right, to the phenomenon, and the output, the intended or the desired output. And what we want to find is the input, the necessary inputs or appropriate inputs that will give us sort of something close to the desired outputs. Kasi hindi lagi tayo nakakuha, hindi natin eksakto lagi nakukuha yung output. Posibleng we get a rough approximation, or not just rough, but a good approximation to the intended output. So this forward problem can be translated into an inverse problem. So yung katambal niya na inverse problem is, halimbawa, I want the output 5, but what should be added to 2 in order to get 5? Ito naman yung inverse problem. Kasi alam ko yung output. Alam ko yung output. Ang output dapat na gusto ko ay 5. Ang governing principle ay arithmetic. And I know one of the inputs. One of the inputs is 2. All right. And then I need to find what's the output. So basically, find the necessary input along with 2 to get the desired output 5. So that's an inverse problem. And of course, we can say that the answer here is 3. Okay. Now, another example na binigay ko dyan sa text ay modeling problem. Halimbawa, simpleng modeling problem sa Math 17 or sa elementary algebra nyo na halimbawa, I want to find out what's the demand for a certain product if I will sell it at X pesos, all right? And suppose I get this model, D of X, where D of X is, say, a polynomial. It could be sa math, ano ba sa math 36 ang usually binibigay? Usually binibigay ay parabolic, a parabola opening downward, right? But essentially, if you're doing modeling, so you can think of this as the governing principle, okay? Dun sa pagmo-model mo ng demand for your particular product. So if you're selling your product at X pesos, yung demand ay D of X units. So that's our governing principle and basically, or the governing model in this case. And then a forward problem could look like this. How many units will be demanded out of me if I will sell the product, say, at 50 pesos? So halimbawa, if X is 50, how many units will be sold? So in that particular case, D of 50 lang yung solution dun sa forward problem because we want to count ilan yung posibleng bibilhin sa akin, right? So kung si D of X ay explicitly given as a function of X, then all you need to do is to substitute 50 into it, right? Yun yung forward o yung direct problem. Now, the inverse problem version of this situation is asking, how much should I sell the product to get, say, 100 units demanded? So ang inverse problem is find X. Find the necessary input X to the model that will give me D of X equals 100. So nakikita nyo, inverse lang talaga siya. Kabaligtaran ng usual direct problem. All right? So we want to find X such that D of X is equal to 100. And you might realize now na, nga no, kahit sa simpleng inverse problem na to or sa scenario na to, mas madaling computein or mas madaling sagutin yung forward problem. Kasi dun sa forward problem natin dito sa demand modeling, magsasubstitute lang ako dun sa D of X, X equals 50 para makuha yung demand kapag binenta ko siya ng 50 pesos. Pero yung inverse problem mas mahirap, especially if D of X is a nonlinear function. All right? So I need to solve this equation. D of X equals 100. And medyo malas ako kapag yung D of X ay napaka-komplikado. Sa malamang, kailangan nyo nang gumamit ng mga techniques mula sa Math 175 para ma-solve halimbawa yung resulting nonlinear equation. Alright? Now, a more interesting inverse problem na siguro na-encounter nyo na sa Math 36 ay halimbawa, what should be the selling price X So I'm still looking for the input, right? So ibig sabihin, inverse problem pa rin to kasi X yung hinahanap ko. So I need to find X, the selling price X, such that ito yung intended outcome. My intended outcome is that I maximize the demand. So what should be the price so that I get the maximum demand? Okay? And in that particular case, inverse problem pa rin siya, pero mas malaki na dapat yung guiding principles na pinaglalaruan mo o yung rules that are available or yung mga tools that are available at your disposal. So in order to find X such that D of X is maximized, paano nga to ginagawa from your math 30 series? Lahat kayo nakapag 30 series na, di ba? So in this particular case, you just need to find the critical numbers by equating the derivative of d to 0 and then perform the first or the second derivative test. And again, though mas matrabaho to kaysa dun sa inverse problem na to, well, inverse problem pa rin siya, yun nga lang, mas marami tayong tools na kailangan gamitin. Some tools from optimization or analysis. Okay? So are these two examples making sense so far? So are you getting the feel of what inverse problems are? So I hope you realize na parang mas pala, parang sa totoong buhay, sa isang physical phenomenon, mas interesting yung inverse problems. Kasi halimbawa, bakit mo i-predict yung output kung kaya mo naman siyang i-observe? Alright? So halimbawa, why will I, or of course, aside from convenience, why will I need to predict the demand if I sell it for 50 pesos? There are other ways in order to find it, right? So I can just sell the product at 50 pesos and count how much demand yung meron. All right? Kasi yung mga resulta ng forward problems, they can be observed. Kaya nga usually ang ginagamit kong term to describe forward problem is predicting the output given the inputs. Because I'm really predicting it using a model kasi ang alternative ko ron ay I'll just observe the phenomenon itself. Pero mas maganda kasi yung inverse problem for me kasi nakokontrol natin yung phenomenon. Alright? Okay. For instance, we go to a more high-tech quote-unquote model, inverse problem. So I gave here the example of controlling the Laplace equation. Now, the Laplace equation is the governing law or the governing principle for the flow of heat in a domain R. So yung flow ng heat, at least yung steady state heat. When we say steady state heat, parang yan yung long-term behavior ng heat. So ginawa ko lang, i-consider lang natin yung steady state heat para hindi na natin kunin yung time variable or hindi na natin kailangan i-consider yung time dependency. So think of it of steady state heat to be ito yung average heat, okay, on a particular area. So halimbawa meron kang induction cooker or meron kang griddle. Yung pang alam niyo pa ba guys yung Angel's Burger o sa mga posh na burger shops na kayo kumakain. Pero kung alam niyo yung Angel's Burger, so makikita mo sa bintana sa nagluluto si ate o si kuya, right? It's a flat surface, right? Na may heat source, right? So if you want to model the heat flow in that griddle, so pwede mo siyang tingnan as something that satisfies the Laplace equation, all right? So the Laplace equation is this partial differential equation here. The Laplacian u equals 0. So basically, itong Laplacian u is just the sum of the second derivatives of the function u, right? Bakit sum of the second order partial derivatives? Kasi si u, it could be a function of several variables. So here, u represents the temperature. And then halimbawa, nasa two dimensions tayo. Halimbawa, si r ay subset ng r squared. Okay? Nasa two-dimensional space tayo, parang yung griddle nga, or rectangular domain. Okay? So meron kang diyang point xy. Yung u of xy, siya yung steady state temperature dun sa point xy. So if you know an address or a coordinate of points on the griddle R or on the rectangular domain R, i-plug in mo lang yung x at saka y component niya to the function u, then you get the steady state temperature. Now, in this particular scenario, the function u representing the steady state temperature on the domain R satisfies a very simple partial differential equation. Ano yung partial differential equation na yun? Ito yun. Yung Laplacian ng u ay equal kay 0. Shortcut lang yung delta u equals 0, but essentially what delta u, that's called the Laplacian operator, and it's just the sum of the second order partial derivatives. So si u ngayon ay function ng dalawang variables, x at saka y, kasi nasa 2 dimensions tayo. Kung ang gusto mong pag-aralan ay heat flow sa isang kwarto, which is 3-dimensional, pwede pa rin. So si u mo ay function ng x, y, and z. But for simplicity, kunin ko lang yung 2D case, alright? So basically, Laplacian ng u ay partial ni u with respect to x pero second order plus Laplacian, partial derivative ni u ngayon with respect to y naman, okay? Tapos the sum should be equal to 0. Yung nga pala yung taas. Okay, right. So kung 3-dimensional yan, edi meron ka pang plus second partial ni u with respect to z. Alright? So ito lang yung equation na nagsasabi paano nagfo-flow yung heat. Alright? So the forward problem in this particular scenario, so ang governing principle o governing law natin ay yung Laplace equation. Yung delta u, Laplacian ni u ay equal kay 0. Now the inputs, alright, ay yung boundary conditions. If you're familiar with ODEs or PDEs, lagi silang may kasamang boundary conditions para masabi natin ano yung unique solution. So the boundary conditions for this particular problem could be, say, the temperature at the sides. So meron ka ditong temperature dun sa western side, temperature sa northern side, temperature sa southern side, saka temperature sa eastern side. Okay? So ito yung additional input. So halimbawa, yung heat source ay dito sila nakalagay dun sa sides ng rectangle. And then syempre, kung may heat source dyan sa apat na sides ng triangle, yung temperature na yon dun sa apat na sides na yon will determine how the temperature inside the domain R will look like, or how will it behave. Pero still, it's governed by the Laplace equation. So if you want to predict the temperature on the interior of the domain R, then what we'll need to do is to solve the partial differential equation, which is a boundary value problem. So we want to solve, or we want to find the function u representing the temperature on the domain R such that its Laplacian is equal to 0 plus the given inputs. The inputs are the boundary conditions. Sorry, T1 to T4 pala yung ginamit ko rito. So temperature sa northern, sa eastern, sa western, at saka sa southern boundary. So usually, if you have a PDE like this, a Laplacian equation, having knowledge of these 4 functions, the boundary functions, all right, will give us the unique solution to the function u. So kaya nating i-predict ano yung temperature sa kahit na anong point doon sa rectangular domain as long as I know what T1, T2, T3, and T4 are, at saka plus kung marunong ako mag-solve ng PDE, which would be my governing principle. Alright? Pero yun nga, so bakit pa ako kailangan magpakahirap na mag-solve ng PDE? Kung pwede na lang kumuha ng thermometer tapos i-measure yung temperature doon sa point doon sa rectangular domain R. All right? Of course, there are some use to it, pero basically yun yung isipin ng isang layman. Bakit pa ako mag-solve nan? In other words, there are some alternatives into doing it. All right? That's why I find the inverse problem more interesting. Now, a sample inverse problem for this is, nasaan na siya? Okay, it's this one, all right? So, meron na talaga akong griddle, ano? So, now, in this particular case, gusto kong magluto ng dalawang magkaibang dishes on the same griddle. Say, I want to cook a steak, ano? Tapos gusto ko yung isa medyo sunog, so well done. Yung isa gusto ko medium rare lang. But I wanna save energy and then use the same griddle. Lulutuin ko na sila ng sabay. Alright? So, hindi ko sure kung tama itong temperature, pero halimbawa dun sa isang cut, gusto ko 40 degrees, kailangan ko siyang lutuin sa temperature 40 degrees. Yung isang cut, kailangan ko siyang ilutuin using 100 degree Celsius na part ng. Alright. I want to determine the inputs. What are the inputs again? The inputs are the temperature on the heat source, which are located on the boundary of the griddle, so that I get the intended output. What's the intended output? A 40-degree temperature on this pale yellow region and 100 degree Celsius temperature on this bright yellow section. Okay? Now, ito yung, nandito ba si Jeff? Ito yung inumpisang pag-aralan ni Jeff nung nag-practicum siya under me last summer. So we are trying to see the possibility of controlling the temperature in a rectangular domain. Si Denmark, nag-research din yan over the summer. Nag-practicum din siya sa akin. Ang tinignan niya yung forward problem, numerical methods kung paano ma-solve yung forward problem. And then a nice complement to it is Jeff's research, which was solving the inverse problem, right? So I hope this will give you some idea kung ano yung mga inverse problems and what are the problems that you can work on for the final project. And yung mga mag-ESP sa akin dyan, start thinking about ano yung interesting sa inyo na phenomenon na pwede nating gawa ng inverse problem. And that's what I want you to do in homework 1.2, right? Mag-start na kayo mag-isip ng isang phenomenon na feeling nyo ay kaya nyong i-describe or kaya nyo mag-define sa kanya ng isang inverse problem. So in that particular homework, you don't need to know the math. Hindi pa natin kailangan malaman kung kaya ba natin siyang i-solve, kaya ba natin siyang i-model. Basta think of a scenario, think of a particular phenomenon, and define an inverse problem on it, right? So wag niyo munang isipin kung kaya ko bang i-model to. PDE ba yung lalabas? Or integral equation ba yung lalabas? Or within our powers ba yung math na lalabas sa kanya? So just be as creative as possible, think outside of the box, but keep the problem in your sphere of interest para pwede niyo siyang gamitin as SP later or kasi mas okay mag-work kapag ka interested kayo dun sa topic. Alright? So yun yung hanapin ko sa homework 1.2. So it could be a short description, no math needed. You can just draw a picture or pwedeng ikwento nyo nga lang sa akin. Think of it as an elevator pitch. So yung parang nag-ano lang tayo, nag-iisip tayo ng startup. So parang ako yung mag-i-invest dun sa startup. So give me a 30-second to 1-minute pitch of what your project is. All right? So, yun pala, pwede kayong mag-multimedia dun sa homework. Pwedeng mag-record kayo ng audio or kung pabida kayo, meron pa kayong PowerPoint slide. That will be greatly appreciated but is not required. I-record nyo tapos bigyan nyo ako ng link via Canvas. Para hindi tayo laging sulat lang. Kasi minsan mas mabilis na sabihin. Hindi kailangan pure English. So, keep it informal, conversational. It's fine with me. Right? Kasi ang goal ko lang naman makita na kaya nyo mag-define ng inverse problems. Okay? And then the first part of the homework 1.1, will rest upon required reading 1.1. I hope you already saw the excerpts from Siltanen's book na shinare ko sa inyo. Sinabi ko rito ay pakibasa yung 17 to 21. Pero mukhang pwede nyo na lang basahin yung pages 17 and 18. So, yun. Nabawasan na yung reading assignment. Tama ba? 17 and 18. Hanggang doon lang sa picture ng strawberry. So, kahit wag niyo munang basahin yung math. So, i-discuss ko na lang yung math sa Monday. Sa Tuesday. Right? Double check ko lang yung page. Yeah, just read kung talagang walang time. Pero, again, it won't hurt if you will read the entire thing. So, pero 17 to 18 lang yung required. Okay? And Okay, sorry about that. Nawalan kami ng internet for some time. Pero I hope nakaabot yung sinabi ko. So, yung reading assignment nyo, pages 17 to 18 na lang. But if you have time, you can continue on 19 to 21. That will be our point of discussion for Thursday. Okay? Any questions? Kung may nagtanong kanina, sorry, hindi ko nakuha kasi I got disconnected. Questions, concerns, clarifications? Okay, so probably at this point, I'll give you some more examples. So, share lang ako ng slides. Yes, Kaiser, any question?
Ah, sir, ano, yung 1.2 is yung recording. Kailangan ba may video? Curious.
Hindi naman. It could be an audio recording. Kasi kung tinatamad kayong magsulat, i-record yun lang yung sarili nyo na nagkikwento kung ano yung inverse problem na naisip nyo or na interesting sa inyo, then that's fine. Right? Because you'll just need to explain to me yung problem.
Tapos po yung 1.1 po, ano po siya?
Aha.
Yung homework 1.1 since 1.2 yung recording.
Yung 1.1 ay naka-PDF siya. So it's a quick essay, So yung homework 1.1 siya yung manggagaling dun sa reading assignment. Sa pages 17 to 18 kasi nung book, nagbigay siya ng tatlong example ng inverse problems, tatlong pictures, or tatlong figures, all right? So what I want you to do is to explain ano yung inverse problem dun sa isa sa tatlong pictures na yan. And yung sasagutan nyo ay nakadepende dun sa inyong student number. So you just need to describe, to explain ano yung inverse problem behind that picture.
Okay, thank you.
Na-assign sa inyo. So, okay, yeah. Masyado bang marami yung homework na yun? I hope it's okay lang. Hold on. Let me share my screen. Okay, so screen ko pala yung i-share ko. So, okay. So, I hope you're seeing my PowerPoint slides, So, some examples para mabigyan kayo ng idea para sa homework 1.1, So, ito yung particular inverse problems of interest ko, especially now in my research. So basically, ang tinitingnan ko ay how to control two kinds of waves, acoustic saka electromagnetic waves. So kung madalas kayo nanonood ng mga presentation ko, ito yung mga mainstay na slides ko, right? So halimbawa, sa propagation ng sound waves or acoustic waves, right? So ito lang yung governing equation. This is what we call the Helmholtz equation, which is kind of similar to the governing principle sa steady heat flow, right? So dito nadagdagan lang ng k squared u yung nasa left-hand side ng equation, right? But essentially same thing, So here I know the governing principles. What I want to do is to find the inputs on the boundary of an acoustic source such that it will propagate desired sound wave F1 and desired wave F2 on regions R1 and R2. So yan yung inverse problem na isa dun sa mga ginagawa ko. Hanapin ano yung acoustic pressure o yung normal velocity nung acoustic pressure doon sa boundary ni DA para ma-achieve ko yung sound profile na F1 sa region R1 at saka sound profile F2 sa region R2, right? And this has several applications na syempre kapag isusulat ko na yung paper, ito yung ibibida ko, right? Because it's a mathematical research. Pero pagkakausap ako ng say isang magfa-fund ng research, ito yung mga examples na ipapakita ko sa kanila. This would be my pitch, right? So say I'll tell them, okay, imagine you're in a room, and then in this room you want to experience different sounds in different parts of the room all at the same time without introducing physical boundaries. So for instance, in this part, you want to hear the news, this part you want to listen or another person of your family would like to listen to audiobooks, yung iba magpi-P-pop dyan or K-pop, and then yung iba naman gustong quiet lang. So, isang room, pero gusto mo ng apat na magkakaibang sound profiles in different areas of the room. So, it will be great if we can design an array of speakers, okay? So that they will broadcast some acoustic signals all at once towards the entire room so that that sound will be perceived as the news in the yellow region, audiobook on the blue region, P-pop on the red, and the black one remains a quiet zone. So the question here is, what should be the input on the four speakers such that news yung maririnig nung nasa yellow zone, audiobook yung maririnig nung nasa blue zone, and so on. So basically, that's my inverse problem. The governing principle, Helmholtz equation, yung Laplacian u plus k squared u equals 0. And then the inputs, the outputs, yung itong apat na sound profiles nito. And then what I'm looking for is the input on the speakers. So that makes this an inverse problem. So, minsan apat na speaker pero yung pinakapangarap ko talaga isang speaker lang. Say nasa gitna ng room, nag-create siya ng sound pero pag nandun ka sa yellow zone, news yung maririnig mo. Pag tumungtong ka na sa audio zone, dun sa blue zone, audiobook na yung maririnig mo. And so on. Okay, so this is one application. Another application ay yung sa active noise cancelling headphones, all right? So ito naman mas effective na pang minimize ng noise from the outside if you want to hear music more clearly, all right? Or halimbawa sumakay ka ng eroplano, ito na-experience ko to. Pag sakay ng eroplano, di ba, may low humming sound ka marinig, the noise from the engine of the plane. Pag nag-headphones ka na usual, syempre mabablock yung parts nung low humming sound na yun. Pero hindi niya gaanong na-filter, right? Kasi nakadepende lang tayo dun sa physical property ng headphone na sinusuot natin. Pero kapag meron kang active noise cancelling headphone, ulitin natin yung animation, ano? Pag meron kang active noise cancelling headphone, so meron kang noise. All right. So, tapos ang gagawin ni active noise cancelling headphone, i-measure niya ano yung profile ng noise. Tapos kailangan niyang pag-aralan yung noise na yon para makapag-create siya ng pang-cancel dun sa noise na yon. Kaya siya active noise cancelling. Kasi may ginagawa yung headphone natin aside from just the padding providing us the desired acoustic experience, ano? So ang ginagawa ng active noise cancelling headphone, mini-measure niya yung noise so that makakapag-create siya ng green wave. Yung green wave na to, ito yung complete anti-phase ng incoming noise. Para kapag silang dalawa ay nag-superimpose, alright? So halimbawa, this particular part, hopefully yung cursor ko ay nakikita, pero hindi pala ako mag-annotate, no? Okay, so sa part na to, magka-cancel na yung noise at saka yung sound na generate ni headphone. So ang net effect nito, zero sound from the outside. Kasi yung noise na paparating, which is the yellow wave, ay kinancel na ng green wave, right? And there's an inverse problem here because it is the circuitry of the headphone that is determining ano dapat yung i-create ko na input, which is basically what is the green acoustic wave here that will cancel the incoming noise, right? Ano pa bang mga application na nilagay ko rito? Right, so lots of examples, right? So ito yung variation kanina, room problem na kinikwento ko sa inyo kanina. So personal audio zones sa car cabins, right? So para halimbawa, paano dapat mag-work yung speakers, ano dapat yung sound na i-produce yung speakers inside a car so that yung naririnig lang ni driver ay say yung Waze o yung Google Maps na prompts. Kahit nag-heavy metal si katabing passenger at kahit nanonood ng movies yung mga nasa likod, right? And lots of car companies are investing a lot in perfecting this technology. Pero nakita ko meron ay si Hyundai, meron na silang prototypes for this particular application, right? And then ano pa ba? Okay. So aside from sound waves, medyo nag-work din ako sa electromagnetic waves in that particular scenario, or our governing equation is this Maxwell system. A bit more complicated than the Helmholtz equation. Kung gusto nyo mag-SP dyan, I can teach you this equation. Pero for now, let's just admire the beauty of this equation. All right. So ano yung mga examples niya sa warfare? Ano? So halimbawa meron kang enemy radar dito. So yung nasa transmitter. So ang gagawin ni enemy radar, magsisend siya ng electromagnetic signals sa air. Alright? And then it will bounce off the ionosphere natin. Tapos pag merong enemy plane, so tatama yung reflected electromagnetic waves from the ionosphere, tatama dun sa enemy plane, all right? And then that wave will create sort of an echo. So madi-distort yung electromagnetic wave na babalik dun sa receiver on the ground. All right? And then depende dun sa incoming electromagnetic waves galing dito sa pagtama kay plane, kayang i-compute o i-detect nung receiver sa ground na, oh, meron dumaan na plane. Kasi ganito yung na-receive natin na echo o na red signal. Right? So what we are doing is trying to determine paano dapat or ano dapat yung ilalabas na electromagnetic wave ni fighter jet. Kasi ang gagawin namin, lalagyan namin si fighter jet ng microstrip antennas or microstrip patches. Tapos yung microstrip patches na yan, mag-create siya ng electromagnetic wave. So that would be the unknown input in this scenario. So I want to find the necessary input, which would be the electromagnetic wave to be created by the microstrip patches para makancel niya yung incoming electromagnetic signal from the ionosphere. Para pag nagbato si transmitter ng electromagnetic signal, tatama siya kay plane, pero si airplane ko magpo-produce siya ng opposite nung incoming electromagnetic signal para mag-zero yung echo na madidetect ni receiver. Alright? So para hindi siya madetect nung radar. Or even more interesting, how to create electromagnetic decoys. When we say electromagnetic decoys, kasi di ba nakadepende kasi dun sa material yung magiging electromagnetic echo. So merong magpapadala ng signal dito sa aking naka-off yung active mechanism ni decoy ko, right? So magki-create siya ng signature, etong blue. So yung blue, pwede yung ma-detect ng kalaban, alright? I-analyze niya, meron akong maliit na object. Pero what if the decoy is equipped with electromagnetic antennas that I can control? Ibig sabihin, kaya kong computein ano yung inputs dun sa electromagnetic decoy para mag-produce ng electromagnetic wave para yung i-create niya na echo, which is the blue wave na pwedeng ma-measure ng kalaban, ay magmukhang malaking object yung decoy ko. So imagine you have a reconnaissance drone, a small drone flying over the enemy territory, pero pag tiningnan ni enemy sa kanyang radar, parang may fighter jet. So magte-take siya ngayon ng isang defensive stance. So you can fool your enemy into thinking that you have a fighter jet around the area even though meron ka lang maliit na drone. So yun yung mga examples ng inverse problems na interested ako. So yun yung mga ginagawa ko for now. But siguro another example, puro example tayo ngayon. No? So okay lang naman yan kasi hindi naman ganun ka-heavy yung math. So in tomography. So this is in X-rays, CT scans. So in traditional X-ray, that's X-ray tomography. CT scan is computerized tomography scans. So ang ginagawa natin dito ay So ang ginagawa natin sa tomography, meron tayong halimbawa 3-dimensional object. And we want to capture some data from this object so that mas mababa yung dimension. Alright, pero dito sa example na to, I have a 3D object, itong nasa cube, alright? And I want to get tomography, meaning I want to take a one dimension less. So kung 3D yung given, gusto kong kumuha ng 2D projection ng given image. Ang ginagawa ng tomography, kumukuha siya ng slices. Alright? So ang example ng tomographic slices ay itong S1 at saka si S2. So what happened here, kunin ko yung pen ko or my computer. Okay, there we go, I can write. So ang parang nangyayari dito to get a tomographic slice, parang kukuha ka ng isang kutsilyo, tapos ika-cut mo yung 3D object mo here. So ika-cut mo yan down. Tapos yung makukuha mong image, ito yung tomographic slice. So kung dito ka nag-slice, dito sa line na to, alright? Yung picture na makukuha mo is a two-dimensional piece of the entire 3D puzzle. So ito yung makukuha mo. So ito yung isang tomographic slice. Pag yan lang yung slice na consider mo, sasabihin mo, meron akong triangle at saka parang cylindrical, alright? Kasi 2D naging ano lang siya, naging rectangular prism pero cylinder siya talaga. Pero if you take another slice, halimbawa dito ka naman nag-slice, ni-slice down mo yan, ito naman yung makukuha mong tomographic slice. And then what we'll do is we get a bunch of these slices. And then using these pieces, we want to piece together the entire picture, the entire picture. Gusto nating malaman ano yung 3D object using this bunch of two-dimensional scans of the object, right? Etong P, hindi siya tomographic slice. Isa siyang projection, alright? Kasi ang tomographic slice dapat laging parang kinakat mo siya. Nagpapadaan ka ng isang cutting plane dun sa object, alright? So sige nga, ano dapat yung itsura ng ng P kung gusto kong magkaroon ng tomographic slice dito sa part na to? Can you imagine ano dapat yung itsura niya? Kasi yung ginawa ni P, parang finlaten niya lang yung object, or parang tiningnan niya lang yung side view ng object. Pero hindi siya tomographic slice. Isa siyang projective slice. Ano? So kung gusto mo makuha ng tomographic slice, dapat ika-cut mo siya horizontally. So meron kang, hold on, clear ko lang to. Meron kang slicer dito. Tapos ika-cut mo siya horizontally, alright? So ibig sabihin kung gusto ko 'tong maging tomographic slice, dapat siya ay nakahiga, right? And then what I'll see is what? I'll see say a circle, another circle, another circle, and another circle. Tama? Kasi pag kinat ko yan dito, circular pa rin yung makikita ko sa cone. Alright? So parang kinuha mo lang yung isang slice na horizontal. Alright? Clear ba yun? Yun yung example ng tomographic slice dito. Okay, and then this is very useful katulad sa X-ray. Ganito nag-work kasi yung mga X-rays natin. So meron tayong X-ray. So ayan yung guiding and then how X-ray behaves or how X-rays travel, yun yung guiding principle natin. Tapos ang input natin ay yung person o yung body that is subjected to the X-ray. Right? And then the output in this scenario would be the attenuated signal that is detected by the detectors dun sa ilalim. Kasi nangyayari, magbubuga to ng X-ray, dadaan yan sa body natin, pero kasi nadidiminish yung intensity ng X-ray habang dumadaan siya sa physical objects. Alright? So kung halimbawa bone yung dinaanan niya, so maraming X-ray yung mawawala. They will be lost in the medium. So ibig sabihin, konti na lang yung pupunta kay detector kasi dumaan siya sa bone, then ang X-ray madali siyang ma-attenuate. So ang term ay attenuate. Pangit ko magsulat siya. Pero anyway, na-attenuate yung X-ray, ibig sabihin nababawasan yung intensity ng X-ray, so konti lang yung madidetect ni detectors. Tapos pero kung dumaan siya sa soft tissue, mas malaki yung mas maraming X-ray yung nakakatakas dun sa body, or mas malaking X-ray yung natitira at nakakarating dun sa detectors. So ang output dito ay yung amount nung X-ray na natira, or better yet yung attenuated X-ray. Gaano karaming X-ray yung nawala along the process. Right? Yun yung forward problem. But in X-ray tomography, ang ginagawa ng mga radiologist man tawag sa kanila, yung mga X-ray experts, ang ginagawa nila ay inverse problem. Kasi ito nga naman, ito yung phenomenon, hindi nila kailangang i-predict yung attenuated X-ray o ganong X-ray yung nawala. Right? Kasi yun yung data na nanggagaling dun sa entire process. So they don't need to detect how much X-ray was attenuated in the process. They have measurement devices for it. And the goal for them is to reconstruct ano yung inside of the body given the attenuated signal. Yun yung inverse problem. So I know the output. I know the output, which is basically how much X-ray was lost when it traveled through the body. My problem is to find the input. What was the input in this process? Ano yung itsura ng internal organs na dinaanan ng X-ray? Yun yung inverse problem dito, right? So one example, ito rin yun. All right. So halimbawa ito, isang example. And this is from the slides of Silton. Ano, so, pero nagpaalam ako sa kanya nung na-meet ko siya sa Albania. Sabi ko, i-share ko sa students ko yung slides mo. Pumayag naman siya, no? So, halimbawa ito, sa head CT scan. So, kapag ka nandito yung X-ray source, dumaan siya rito, makikita nyo, dadaan siya dito sa part na to, which is composed of, say, lots of skull material. Ito, skull din. So, malaki yung attenuated signal. Malaki yung nawalang X-ray. Pero dito, dahil wala siyang dinaanan, makikita nyo zero yung attenuated signal. Alright? Ibig sabihin, walang nawalang X-ray dito, kaya mababa yung mababa yung value ng graph dyan kasi walang nawala. Alright? Kasi nga, wala pa siyang nadaanan na object. Tapos yung nandito, medyo dito, medyo mababa lang yung nawalang X-ray kasi nga dito soft tissue lang naman yung dinaanan niya. Pero compare dito, hindi lang straight yung pagkakadrawing, marami siyang bone structures na dinaanan or skull structure na dinaanan. Kaya, ang laki nung na-attenuate o na nawala na signal. Alright? Tapos ang data na makukuha ng mga X-ray technicians natin o yung mga radiologists natin ay ito. Yan yung data na meron sila. Hold on. Nagrereklamo si Teams ko. Okay, hopefully I'm back. So, sorry. Pero essentially, ayun yung nangyari. So, sorry. Nagloloko na naman sa internet. So, yeah. Here, ulitin ko lang. Hindi ko alam kung na-capture. So, dito sa part na to, malaki yung nawalang signal. Kaya ang laki ng value nung yellow curve. Kasi nga, marami siyang dinaanan na bones. At kakaunti lang yung nakaka-penetrate na X-ray through bones. Okay? Ayan, sorry na wala yata uli ako doon. Ito ang hirap ng no? Ayan. Sorry about that. Internet problems. Hirap ng prime time pala yung klase, no? Pero I hope I'm back. Hold on. Sige, ulitin ko yung share screen. Okay. So can you guys see my screen? Kita nyo ba yung screen ko?
Yes po po.
Yes po, sir.
Okay, thank you. All right, so here I have a video. Ito yung nangyayari kapag nag-X-ray tomography tayo. All right, thank you. So ito yung input, itong skull. All right, so basically yan yung body part na ini-scan. Tapos nandito sa mga dots, ito yung X-ray signal. Tapos ibobombard niya or ibobombard niya yung input by X-rays, tapos i-measure natin gaano karaming X-ray yung nawala. Yun yung pinapakita nitong white curve, ano? So here, yung white dot, naglabas siya ng X-ray, itong top dot, alright? Walang nawala kasi wala siyang dinaanan na part ng head, kaya zero yung value ng white curve, alright? Pero dito, sa part na to, alright, nagpadala siya ng X-ray pero dumaan sa skull, soft tissue, skull uli, soft tissue, skull, and so on. Marami skull material or bone material, so kaya malaki yung attenuate na signal. Kaya lang, kapag ka ito lang, so kung ang data mo ay ito lang, itong 2D curve, alright, medyo mahirap i-reconstruct yan. Kaya ang ginagawa sa CT scan, sa sa next week ay start na tayo ng math about these things. Ano? Tingnan ko nga to. Okay. Alright. So, kapag ka ito lang yung ginawa natin, if we fix the X-ray sources on one location, makakuha tayo ng ganitong klase ng data. Limited yung information na makukuha natin about the object being scanned. Alright? So ito yung traditional X-ray. Ganito lang yung nangyari. Di ba pag nagpapa-X-ray tayo, nakatayo lang tayo, nakaharap tayo sa X-ray source, tapos may film sa likod natin. Yung film, yun yung nagka-capture nung natitirang X-ray. Tapos kinocompute nila ano yung nawalang X-ray, tapos mula doon nire-reconstruct nila yung internal organs natin. Right? Pero sa CT scan, niro-rotate nila yung X-ray source. So they are taking measurements of the attenuated X-rays from different angles. So parang ganito yung nangyayari. Let me know kung wala kayo nakikitang video, right? But you should see a video right now. So umiikot siya, umiikot. And then this will give them a better view of what is happening inside the body, all right? Kasi mas marami silang data na kinukuha, and then they're using this bunch of measurements from different angles. Of course, there's a lot of math involved kasi ngayon yung natitirang X-ray o the attenuated X-ray o yung nawawalang X-ray upon passing through the head ay nagiging angle kung saan nakaposition yung X-ray sources. And then from that data, tinatry nilang i-reconstruct ano yung nangyayari. Okay? So, let's see. So, naputol ba ako?
Rinig po, sir.
Okay. All right, thank you. So, pero ganito yung nangyayari. So, sa totoong buhay, hindi natin alam ano yung itsura ng head, ano yung nangyayari sa internal organs, and yet we are getting this data, yung yellow data lang yung nakukuha ng mga doktor, ng mga technician ng CT scans. Tapos mula dito sa yellow data, tinatry nilang i-reconstruct kung ano yung nangyayari dun sa internal organs. Alright? And then now, to end the class, or sort of hindi pa pala end, itatry kong tingnan kung kayo ay mga natural tomographer. Tingnan natin kung magagaling kayong mga inverse problem solvers. Ano? So I will give you a bunch of measurements, tapos huhulaan nyo kung ano yung object na iniscan. Alright? So if you have your other devices with you, join me in Slido. Hold on. Bakit tayo mag-work ng Slido ka? Ayaw mag-work ng slide ko na may Slido. Alright. But anyway, please join. Itatype ko na lang sa chat box yung Slido number. Ano? Para hindi nyo makita yung sagot. Hold on. There we go. Lalagay ko sa chat yung Slido number. So, punta kayo sa slido.com. Tapos, join kayo dito. Hindi ko rin siya makopy-paste. Hold on, guys. Ano nangyayari? Copy. Ayan, there we go. Sorry, napalaki yung copy-paste ko. So go at slido.com and then join the session 1265994. Again, go at slido.com and then join session number 1265994. So hopefully, gumana siya. Naka-join ba kayo?
Yes po, sir.
Alright. Ayan, naglo-load pa lang pala siya. Napaka-impatient ko lang. Sige, share screen na uli ako ng slides. So ano lang naman to, bonus points. So I will show you, so I hope you are seeing my screen now. So I'll show you some X-ray data or some CT scan data. Tas hulaan nyo ano yung image na ini-scan ko para makuha yun. Right? So let's see. Question number 1. Okay. So ito yung object. Alright? So papakita ko yung animation. Hulaan nyo kung ano kaya yung ini-scan. Alright? Here we go. Remember, si yellow siya yung, siya yung nawawalang X-ray. Alright? So ito yung na-attenuate na X-ray. So again, right? Ano kayang object yung na-scan, right? So here are your options. Okay, join the quiz, pero 0 participants pa yung nakalagay. Ayun pala, paki-edit yung name nyo. Pwedeng nickname and last name. Kasi i-record ko to, di ba? So para hindi ako para alam ko kung kaninong score. Okay, sige, edit nyo lang. Actually, pwede na rin naman palang first name, lalo na kung lalo na kung wala kayong kapangalan naman sa klase. So, wait, naka-join na ba lahat? 14, 16, sige, antay pa tayo ng mga 1 minute. Okay, 18. Okay na? Ready na? Game na? Okay. So, nakita nyo na yung first question. So, anong object kaya yung in-scan? 15 seconds? Circle ba yan? Pentagon ba yan? Triangle? Or none of the above? Okay. Tingnan natin. 42% nagsabing triangle. Let's see. Oh, may mga nag-pentagon and circles. Let's see. The answer is a triangle. Bakit siya triangle? Tingnan natin. So si Alex yung front runner natin. Ito yung nangyari. Alright? So kita nyo sa side na to, okay, so sa side na to, hopefully kita nyo yung cursor ko. Dito ay ang daming dinaanan ng X-ray, right? So a lot of parts of the triangles were traversed by the X-ray, kaya ang daming X-ray yung nawala. Alright? So remember, ito yung measure, yung yellow, measure ng gaano karaming X-ray yung nawala. So if we start the animation again, so dito, wala pang nawala, kaya 0 yan. Pero dito sa part na to, ang laki na nung nawala. Kaya ganito yung value. Dito ko konti pa lang yung dinaanan ng X-ray, kaya konti pa lang yung X-ray na nawala. Alright? So hopefully, this gives you an idea. Meron pang 3 questions. So ganun yung nangyayari, alright? So sana mas marami na sa 42% yung makatama sa susunod. Next question. Okay, ito yung next object, right? So sige, tingnan nyo muna to. Imagine ko ano yung nangyayari. Alright? Tapos, sige, sabihin ko na yung options para makapag-isip na kayo. Options ay letter S, letter B, letter W, or none of the above. Yun yung mga options para sa object na to. And then, let me play the animation. Okay, ulitin natin. Okay, isa pa. Sige, isa pa. S, B, or W. Ano yung ini-scan ko dito? Right? So here are our options. Oops. S, B, or W? Oh, hula na. May 3 pa hindi nakakasagot. Natin. Okay, 41% nagsabing W. The answer is letter B. Right? Bakit siya letter B? Ito yung sagot. Si Victor na ang leading. Okay, so ito yung nangyari. Di ba ang hirap pala, no? Ang hirap pala ng trabaho ng mga nag-i-interpret ng X-rays. Kasi kahit visually at simple objects lang yung ginamit, medyo mahirap siyang i-predict, right? Sige. Let's see. Third object. Ano nga ba to? Alright, ulit. Dapat pala kita nyo na yung options para mas madaling mamili, no? Para side by side with the animation. Next time. Alright. So ito yung options. Oops. Anong emoji? Sorry, ngayon ko lang na-realize, mahirap pala siyang hulaan. Dapat side by side yung option saka yung emoji. Ano? Anong hinula nyo? Let's see. Actually, nung pina-quiz namin to, ang sagot ko rin ay letter A. Pero ang sagot pala ay letter C. Alright, it's a unicorn. Ano? So let's see, sino pang... Oh, si Daryl, perfect pa rin so far. Galing naman ni Daryl. Ito last. Paano siya yung naging unicorn? So dito sa may horn, super konti pa lang, pero rito dumarami na siya, yung na-attenuate, right? Last problem. Sakit sa ulo, no? So sige, last object na. Ano nga to? Malimutan ko na rin yung sagot dito. Actually, ito yung pinakamahirap. Okay. Ito yung options. Brain na merong missing parts, brain na may tumor, o brain na may unicorn. Sorry, dapat pala talaga sinide by side ko yung options. Next time. Oh, evenly divided. Alright. Wala talaga nagsasagot ng ano. Sagot ay letter C. Oh, let's see. Oh, si Daryl, perfect talaga. Congrats kay Daryl sa top 5 kay Denmark, Victor, Tricia, and Carlo. So, yan yung bonus points niya for today, right? So, here's the solution. Ano? Pero mahirap siya, no? Kasi yung object na naka-embed ay mahirap ma-determine. Ano? So, that's why we need several readings. I mean, we should use a lot of angles in order to map out the complicated portion of this image. So at this point, end of game. Next time na lang ulit. Pero yun nga, dapat pala side by side ko siya gagawin. Right? So remember this, ito yung scan mula dun sa head na pinakita ko dun sa umpisa, right? So how do we try to reconstruct it? So parang pinapaste together ko itong mga readings na to. So let me shift slides here. So ganito yung nangyayari. Ito yung data mula dun sa human head. Tapos paano siya nire-reconstruct? So mula dito, ito yung data, yung yellow curve, remember? And I will convert it into this two-dimensional object. There's a transform, a type of operator that will translate this function into this two-dimensional object. All right? So saka na natin pag-aaralan paano na-transform itong one-dimensional curve na to into a 2D object like this. Wherein, if there are lots of attenuated X-ray, kung mas mataas yung attenuation, mas bright white yung conversion dun sa strip na yon. Right? So kaya dito dun sa bottom part, makikita nyo white na white kasi ang daming na-attenuate na signal. Ito rin, napaka-white. Pero dito medyo grayish siya kasi konti lang yung na-attenuate na signal. Right? Pero remember, this is just one angle. So kapag gusto kong i-reconstruct yung image, I will do this for all angles that I used. Sa lahat ng angles na kinunan ko ng measurement, gagawin ko tong two-dimensional rendering na to, then I will paste them together. I will sum them up. So pagpapatong-patungin ko yung mga 2D images na yan para makakuha ng reconstruction ng image na pinadala na iniscan natin. So what I'll do here, this is first measurement. I'll take my second measurement and put it on top of the first. Ito yung mangyari. So meron akong first reading, tas yung second reading ko, ito yung kanyang sinogram, ito yung kanyang graph ng attenuated signal. Kukunin ko ulit yung transformation niya into a two-dimensional grayscale rendering. Tas ilalagay ko siya on top of the previous one. Kaya makita nyo from simply this image, pag ginamit ko na yung second data or second set of data, yung transformation ng second set of data, ganito na yung makukuha ko. Kaya meron ng diagonal part. Tapos kukuha pa uli ako from another angle, kukuha pa ako ng rendering on another angle. I will transform the data we got, the observation data we got, and I'll put it on top of these two pictures. Ito na yung makukuha ko. And I'll do this for more angles, until it takes some shape. Okay. Oops. Yeah. So makikita nyo, dahil kakaunti lamang yung angles kong ginamit, medyo hindi pa obvious na human head yung iniscan ko. Pero you see, we're getting there. You know? So what we need is to increase the number of angles of observation. And tingnan natin sa YouTube yung resulting projection. So ito naman, same version, pero mas marami akong ginamit na angles of observation. Okay. So ito yung reconstruction na nangyayari. I'm just putting the transform of the data on top of each other. And then I let them superimpose. And then yeah. And then the final figure, you see that, oh, okay, we are getting there. We are getting a good reconstruction of the image that we got. Pero medyo blurry yung image, ano? So dito naman papasok yung image deblurring. How can we improve this? Kasi ang dami na nating measurements and we cannot afford too many measurements. Ano? Medyo mahal mag-scan para lang makakuha ng maraming data. So we use some mathematical tools para ma-improve itong nakuha natin na blurred reconstruction. And what we do, for instance, is we take the fast Fourier transform. So I don't know if you have heard of Fourier transform. Ginagamit din siya. Oops, sorry. Yan, hindi kasi naka-YouTube Prime. Pero I hope you have heard of the Fourier transform. It's another tool that is used to solve partial or ordinary differential equations. So meron akong image, okay? Kukunin ko yung kanyang fast Fourier transform, meaning tina-transform ko siya sa frequency domain. So kung meron ako ditong function f, hindi pala makasulat. Function f representing the image, all right? Siya yung nandito. And then I'll take the Fourier transform or the fast Fourier transform of that image. I'll get this. Ibig sabihin, pinaplot mo lang yung frequencies. Tapos medyo i-highlight ko yung matataas na frequencies. Ano? So I will just scale the frequencies up, right? So meaning, i-multiply ko lang say yung frequency, yung fast Fourier transform by the frequency present, right? Para ito yung nagiging deblurring process. Paano ko na siya sharpen yung image? So fast Fourier transform the blurry image, boost the high frequencies. We will learn this more later, the mathematics behind this. Tapos pag meron na ako, na-boost ko na yung high frequencies, para yung mga blurry images ay mawala, kukunin ko na ngayon yung inverse Fourier transform para makabalik ako dun sa picture form. Kasi itong picture sa top right, ito yung frequency domain. Gusto kong bumalik dun sa actual parang picture domain. Ano? So kukunin ko yung inverse Fourier transform, eto na yung makukuha ko. Right? This is how we de-blur the image. So see the improvement from this blurry image papunta rito. Right? So but these are some tools na pag-aaralan natin, especially sa chapter 1. Titingnan natin ano yung math behind dito sa mga pinanood nating mga videos. All right? And we'll start doing that on Tuesday na lang. But starting Tuesday, we'll start digging into the mathematics behind this, right? But again, dahil nga medyo halo-halo yung background natin, I'll have to introduce some preliminary topics beforehand. Okay, so I think that we can stop here. Sorry about the disconnections na experience ko, right? So saka medyo mahirap pala yung quiz, ano? Dapat pinagtabi ko na talaga yung yung choices at saka yung video. But I hope you had fun and you had some idea about inverse problems. So ready nang gumawa ng homework 1.2? What do you think? Can you finish it before the deadline? I think the deadline for homework, kailan nga ba yung deadline? Sunday nga ba? Yung deadline ng homework 1? September 11, tapos yung homework 2 ay September 12. Can you guys do it? Okay lang ba? Alright. Gusto ko sana ipasubmit ng Sunday para Monday, mabasa ko siya. Tapos, para sa Monday, para sa Tuesday, makapag-comment ako. O nga, inaantay ko nga yung pa-blowout ng my birthday. Kakantahan ba natin si Jace ng happy birthday? Yeah, nakita ko sa post ng sum up na birthday pala ni Jace Saturday. So belated happy birthday uli kay Jace. So sa mga magba-birthday dyan, para ma-shoutout kayo, sendan nyo lang ako ng birthday nyo. Sorry, ganun. Hindi na kasi ngayon masyadong sinishare yung birthday kasi data privacy daw. Hindi ko naman sinabi yung exact date ng birthday ni Jace. So basta nag-birthday siya recently. All right, so I think that's it for today, guys. So I'm looking forward to your homeworks. Wag niyo masyadong dibdibin. So simpleng homework lang yan. So let's just have fun. Kasi last na yan. Sa next week, mag-start na tayo ng pag-aralan yung mathematics behind the behind inverse problems. So doon na tayo medyo magiging seryoso. All right? Thank you, guys, and enjoy the rest of the day. Actually, enjoy the weekend because we'll be meeting na on Tuesday. Sorry. So thank you, guys. Bye.
Bye,
Thank you po, sir.
Thank you, sir.
Thank you, sir.
Thank you po, sir.
Thank you, sir.